All right, my clock is saying 11, so I think we can get started. So I'll just first introduce myself. My name is Kamala Thorpe, and I'm here with Jack Rymack, and we will be doing the webinar today on RoadEng for county engineers. As always, we will be recording the webinar so that you can watch it again or pass it on to anyone else who missed the webinar today. And feel free to ask any questions as we go. There is a question panel that you can type your questions into, and we'll monitor it and answer them as we go. So today's webinar will be done in RoadEng with the Softtree Optimal add-on. RoadEng is a standalone civil design program with two modules. There's the terrain module and the location module, which you will see both of today. The terrain module is where you do your, you read in your survey data and create a digital terrain model, and or work with an existing terrain model. And the location module is where you do your road design. And the Softtree Optimal add-on is for the location module, and it's an optimization program that allows you to design the vertical alignment a bit faster. Won't go into detail about that, but Jack will show you that very briefly as well today. So concepts that Jack will be going through today, a little outline. He will be inputting a total station file, creating a terrain model with that file. And then he'll do a quick road design with cross-section templates, horizontal and vertical alignments. The vertical alignment will be where he shows you what the how the Softtree Optimal add-on can make that part of your design process easier. And he'll show you volume calculations, reporting, and then lastly, he'll show you how to do output in RoadEng, whether to PDF or to a DWG file to pass on to CAD for further drafting. Before I pass things on, here's a list of our upcoming webinars. Got a few scheduled from now until April, so take a look and sign up for any or all of them. We'd love to see you at all of them. Okay, and with that, I will pass things on to Jack.
Thanks, Cam. There we go. Okay, so I'm going to start by opening up a total station file of a terrain in the terrain module. I've already set up the import specs for a total station file. Just going to open it up. The import specs are saved in a ASCII file. And this is the ASCII file right here that I want to open. It's a comma delimited file. The northing is found in the first column, easting is found in the second column, elevation is found in the third column, and there's a code. And let's just take a look at some of the codes. Some of these codes have been connected into line work, such as these codes are numeric, but they can be alphanumeric codes. And some of them have not been connected into line work. This particular code 18 has been connected into line work. Let's take a look at some of the other ones. No, that one hasn't. Anything that usually has an asterisk beside it has been connected into line work. Anyway, you guys got the idea. So let me just open up the file. This is an imperial unit file, so we'll proceed with just designing based on feet and inches and yards for volume, but you can use metric obviously in our software too. So here's all the line work for the file. Like I said, some of this line work has been imported using our import specs that you just showed, that I just showed you just a couple of seconds ago. And some of these features are brake line features. For instance, this feature right here, which is EFL, it's probably a flow line feature of a ditch. That's been connected into a line work and also made into a brake line. Brake lines are features where there's a definite change in slope. Good brake line features are top of cut, toe, fill, edge of road, bottom of ditch. Let me just calculate my tin and contours for this file. Select a point where I want to start my design. generate my contours and my triangles. The top part of the dialog box is the triangles. I'm going to just set it to a reasonable length. If I don't set it to a reasonable length, you're going to get some long triangles across these areas right here, for instance, void areas. Minor contours will be at 1 foot interval. Major contours will be at starting here and ending. Save this file. I'm going to try to keep my demonstration to around 30-35 minutes. So just to keep it simple and easy for you guys, don't want to make things overcomplicated. I'm going to save this file as County Road 2, Module to Location Design. File New is the next step. Open up County Road 2. Start at that current point that I selected. You remember I selected a point down here to start. Terrain current feature current point. There we are, we're starting down here. I'm actually going to move it a little bit over. Start over here instead. Generate it, get a screen layout for horizontal alignment. So these screen layouts, these little pull down screen layouts, set up all your options for a particular type of task. And this part of the demonstration, the task is to design a horizontal alignment. I'm not going to specifically talk about template. I'm just going to show you the template of what it looks like. I'm going to use this template as my default. It's got all the correct settings. This particular template has 6 components of 2 road edge, 2 roads left and right, 2 ditches left and right, mirror images of each other, 2 slopes left and right. You can just double click on a component and change its parameters. In this case, I got asphalt thickness, asphalt width, shoulder slope, and a whole bunch of other parameters. Same with ditches. Ditch depth from subgrade down, ditch and slope, and then ditch bottom width. Most counties usually have a ditch bottom width of about 4 feet for imperial designs. That's what I've seen most of the time, anywhere from 4 to 8 feet. I'm just going to leave it my default of 1 foot. That's fine. It's just for demonstration purposes. That's good enough. Press OK and use that template. Start designing my road. Left click once. Put one IP all the way over here where I'm going to have my first curve. Left click again to tie it down. Move all the way up here to the next point that I'm going to put in an intersection point or PI. Left click, and then I'm going to zoom out and move all the way over here and snap to this point right around there. Jump back using these buttons right here until I get to my second IP. Get my default curve. Apply. So this is going to be a 40 mile per hour design. Based on 40 miles per hour and AASHTO tables, we get a 600-foot radius curve, 6% super, and 200-foot transitions from no super to full super. If you don't want to use AASHTO tables, you can just turn off auto for either the super elevation or the transition length. Just type in your own transition length. If you rely on auto, you will be using these tables. And in this case, the transition is 2/3 transition out, 1/3 transition in. So that's what this 0.667 stands for. So 2/3 of the transition from zero super to full super is going to occur outside of this length of 200, and 1/3 of it will be inside of this length of 200. So 1/3 will be inside the curve and 2/3 will be outside of the curve. Let me set this as my default. Jump forward, get my default, apply. If I decide to move this around, you can see that the software updates everything real time, all your horizontal alignment. All my cross sections update between those two sections, between those two IPs, between the last IP and the second IP. Go on to vertical alignment. Get a screen layout that will set me up for vertical alignment. What you see in the vertical alignment screen, you see a cross section like you did in the horizontal, but this time you see the profile, the vertical design window. You also see underneath the vertical design window or the profile a mass haul diagram. In this case, the mass haul diagram is endlessly cutting. You also see a data window that has mass information and volume information. In cubic yards, like I said, you got cut volume, fill volume, and mass haul. And you got totals. The totals for the fill volume are very small compared to the cut. The cut is in the 14,000 and 15,000 range because we're, like I said, we're endlessly cutting because we're sitting on top of the ground. Haven't done any balancing using our vertical tool. In our profile window, I will start to do that soon. I just wanted to double click on the mass haul and just show you some of these colors and what they mean. Obviously, you're seeing a lot of waste. That's what the red is. Not seeing any borrow. We might see some of that as we do some design. Overhaul, not seeing any of that. It's yellow usually. And green is for free haul. I'm going to change my free haul and my overhaul distance to about 1,000 feet and 3,000 feet. That's more appropriate for an imperial design. Now I can start designing. We got one design point all the way at the beginning of this alignment. All you do is just keep on adding with your pencil tool design points anywhere to the right of that first point. Left click once, left click again, tie it down. If you want to move up an alignment point, then you can just grab it and move it around. Let me just do that again because I did it so fast. Grab it up, move it around a little bit more. You're starting to see a little bit more green happening. Left click anywhere to the right of that last IP. Put in a IP all the way at the, or PI at the top of this hill. You can see we're getting a lot more green and yellow. But we still have red after this point because we haven't done any vertical design yet there. Pull this up a bit more. Get rid of some of that red. Left click. Left click. Left click. Left click. Left click, left click. Oh, we're seeing a little bit more borrow. Let me just try to pull down. If you see borrow, you pull down. If you see waste, you pull up. I'm balanced again. Let me just put an IP all the way at the top of this hill. I got a little bit more borrow on this side now. Get rid of that. So I got a little bit of waste at the end. That's fine. Just going to leave it as where it is. Go to my vertical curve panel and add in my vertical curves. Jump back, just like I did with the horizontal curve panel until you get your second IP, VPI or VIP. Get my default curve, which is set to 40 miles per hour. That will give me a K value of around 53.73. 40 mile per hour curve, K value of 53.73, and a length of curve of about 133 feet, and a site stopping distance of around 326.1. If you want to type in your own K value or your own length, you just turn off auto, If you want to type in your own site stopping distance, just turn off auto over here and type in your own. I'm just going to leave the defaults. Apply. Set this as my default. Jump forward. Get my default. Apply. Get my default. Apply. Jump forward. Get my default. Apply. Jump forward. Get my default. Apply. Jump forward. Get my default. Apply. Okay, got a question here. Yes, you can. The question was, can we run ditch grades? Yes, you can, but you actually have to put a component in called the ditch by elevation component, and I can show you that really quickly. And then you can actually change the elevation of that component at certain stations, and that will help you design that ditch grade. Does that answer your question? Okay, thank you. So yes, you can, but you have to create a separate, you have to put in a separate component, copy that component into my template, and that will be the ditch bottom component. Not going to do that, but just know that it can be done. If you have any specific questions after the next question is, can you set beginning station? Yes. Module setup. Let's just change my alignment. I'm going to change it to 1,000, for instance, or yeah, 1,000 or 10,000. Let's just change it to 1,000. So that will change the start station to 1,000, and then everything will number from there. Does that answer your question? Okay, let's just finish the vertical design. Get my default. Apply. That's the end of my design. I could fix that little bit of a waste issue, but I'm not. I'm going to leave it there. In fact, I'm going to create a little bit more waste just at these points right here. Just so I can show you how to how the software can actually help you solve some of your alignment issues. First of all, let me show you the cost of this road as it was designed by me manually. The cost is $143,000. How do we get that cost? Let me just show you. The costs are based on a material that I have, which is this common material. And cut costs for this common material are $12 per cubic yard. Fill costs are $4 per cubic yard. You can change these costs to whatever your needs are. And hauling costs are split up into three: free haul, overhaul, end haul. Free haul is $8 per cubic yard mile. Overhaul is $4 per cubic yard mile. And end haul is $2 per cubic yard mile. And loading costs, obviously free haul has no loading because you're just pushing the dirt around. And overhaul is 60 cents per cubic yard. End haul is $2.60. You can change those numbers right here by clicking on this button right here, haul costs. Change those numbers right there. I'm not going to, I'm just going to leave it as is, and that's how we got that $143,000. Let me see if the software can do better than this. I'm going to set it up so that the software will actually do a quick optimization for me. And put in some reasonable spacing for cross sections, for sections. Standards, I'm going to do a series of curves and tangents. Minimum curve length will be around 200 feet. My sag, for like I said, the sag crest K value for a 40 mile per hour road is around 55. Anywhere from, I think it was around 53 point something, but I'll just put 55 in there. We're not going to exceed this max min grade, so I'm just going to leave the default. And control points. Control points are places where you want to tie the elevation down to a specific point or attached to the ground. Start of the alignment, I want to attach that to the ground, and the elevation of that point is 1,413 feet. I also might want to put in a grade control, so I'm coming off at a reasonable grade, which is good, minus 1.19, which is reasonable, off an existing road. You might want to tie down the end of the alignment. I'm not going to. But if you do come and attach, if you attach to another road, you have bridge approaches, bridge abutments, and you want to add those as control points, you can do that too. I've seen that done a lot too. I'm not going to put any pits. You can put in bore and waste pits, but that is an option that you can use. And obviously we've talked about costs. I'm not going to talk about any of the other tabs here. Just going to let it run. Process. So now the software will use those design constraints and standards that I put into that panel and figure out the lowest cost vertical alignment for me. Okay. Let me just see what's going on here. Okay, let me just do one thing. I'm just going to get rid of that control point and process it again. Just because I changed that station, I don't want to deal with it. It looks like it's working now. It's coming out to a cost so far of $82,000. And at this point, we are at most 25% away from optimal in the worst case scenario. So if you let this run down to 0, it will obviously find the optimal solution. I'm going to stop it right now. I'm fine with, this could be the optimal solution right here. I don't know, but let me see what the result is. It's telling me that I have an overflow of 23.8 cubic yards of material. I'm not going to put in a waste pit. I'm just going to leave it where it is. Set this as my current alignment. So there's the alignment of a, it's pretty well balanced, you can see. Lots of free haul. All right. Next thing, I got about 6 or 10 minutes to show you the output sheets and also show you a quick drive-through. I wanted to show you a drive-through of this road after you've designed it. I'm going to get a screen layout here for output sheets. Plan profile. Change my size of sheet. And landscape. We have 100-foot stations here. You could change your pagination so you're showing more or less stations per page. Let me try see what 2,000 gives me. I think I should be able to fit 2,000 in there. And modify this to reset it to auto so that it's lined up with the profile window. We've got 3 pages. If something doesn't fit on a page, you can shift it around or rotate it. Let me just try shifting this around. Or I'm going to just change the pagination back to something a little bit less, maybe 1,500. That'll give me one more page, but it might be able to fit things a little bit better. There. All right, now all of these can be saved to DWG or PDF. Any of our output sheets or plan profile sheets, section sheets can all be saved to PDF. So all you do is go File, Save As, or DWG. I'm going to first of all save it as a DWG file called County Road and save my multi-plot. Done. And you can also save as PDF or print to PDF. Let me just show you quickly how an output sheet of cross sections looks like. So this has been set up for 100-foot intervals. Two by 2. If you can fit more cross sections per page, you can change this to 3 by 3, for instance. And we are looking at cross sections at 100-foot intervals, like I said. And we're going bottom up. If you want to go top down, you just toggle that off. Yeah, we can fit nicely 3 sections per page. And if you want to, you can change. I only have major grids here turned on. You can also turn on grid lines for minor grids. Let me just change the format of my, first of all, major grids. Make them hairline, solid hairline. And my minor grids will be dot. And my major grids will be a dark color, which they are. Minor grids will be a lighter color. So there's your grid lines, both major and minor grid lines. You can change your grid spacing too. Okay, and again, this can be saved to PDF and DWG. Let me just show you really quick. I'm going to go back to my original horizontal screen, and I'm going to set it up so that I can export this out to do a drive-through. I'm just going to drive through along the subgrade instead of exporting the entire finished search. I'm just going to drive through the subgrade. File, Save As, a terrain file. Select the one that I just did a few minutes ago before I started this demo. All points, and I'm going to just change my spacing for this, for auto intervals, to 5 so I get more cross sections, so it's a little bit smoother of a drive-through. And turn on boundary, surface limits, and make sure I got the right template codes. Remove all of these, add ditches, ditch inside, ditch outside, road edge, and slope stake, left and slope stake right, and also my center line, which is up here. And make sure all of these are brake line features. and it's exporting now. Let's just go back to my terrain. Once it's exported, go back to my terrain and merge it. Press the merge button, which is up here. Turn off a couple of these options. Browse. Done. Okay. One more thing I'm going to do before I do my drive-through is I'm going to make this feature a different line type. It's a little bit, I'm just going to change it so that there's no squares at any of the cross sections. And then make sure I go window, new window, graphics, 3D. Oh, wait a minute, I have to generate my tin. I'm not going to do contours, I'm just going to generate my tin. There's my tin. Right click, drive through flyby. Play. Start the drive through really slowly, but I'm going to speed it up. Try to go around 100 miles per hour. And then once you get to the end of your road, you can obviously reverse it and play it the other way. Just go faster until we get to the other side. I think you guys got the point. Let me just say thank you very much, and this is the end of my demonstration, and please join us in the next coming weeks, as Cam showed you at the beginning of the demonstration. All of the demos, the future demos that are coming up. Thank you. Thank you very much. Please join us again.